When severe torrential downpours finally clear the rural mountainous valleys of Honduras, locals step outside to find a harvest that shouldn't exist. The inland fields and dirt streets are blanketed with thousands of live, silver-scaled fish left flopping on the wet ground. These are ocean-dwelling creatures, yet the terrain sits dozens of miles away from the nearest saltwater coast. Observers documented this as a recurring meteorological event for decades, finding no evidence of a hoax. The origin of the phenomenon lies out over the open ocean, where a violent atmospheric catalyst is already in motion. Out at sea, severe storm cells clash directly over the water, creating extreme pressure differentials right above the surface. Those whirling updrafts wind into a focused vortex, creating a massive waterspout that connects the dark cloud deck to the sea. This cross-section of a waterspout funnel shows a low-pressure core generating strong internal vertical velocity. A bar chart tracks internal wind speed accelerating past 100 miles per hour, hitting the kinetic threshold to lift solid mass. As the vortex touches down, it aspirates the ocean's surface. Any aquatic life swimming near the surface is caught in the current and pulled into a rapid vertical ascent. The waterspout acts as an extraction tool, stripping mass from the ocean biosphere and injecting it into the sky. Once vertical lift is complete, horizontal momentum takes over. The fish enter a massive storm cell, providing enough atmospheric volume to harbor the heavy cargo. Powerful, continuous updrafts trap the payload in the cloud layer, blocking it from falling back to Earth. This topographical map tracks the storm system pushing steadily inland, away from the coast. Regional topography dictates the destination, as large mountain ranges act as natural walls, channeling the system directly into isolated inland areas like Yoro. The storm maintains the kinetic energy required to transport thousands of pounds of aquatic life over dozens of miles. The upper atmosphere temporarily functions as a high-speed transit system, overriding the boundaries between the ocean and the land. Eventually, the storm cell collides with the dense, mountainous terrain surrounding Yoro. The sudden friction causes the internal structure to collapse. The updrafts fail, and the wind speed drops below the gravitational threshold. The invisible atmospheric floor drops out, and thousands of fish plummet from the cloud deck in a sudden, simultaneous release. The violent physics of the journey gives way to a surreal aftermath as the ocean life lands on terrestrial grass. The Lluvia de Peces is a localized demonstration of fluid dynamics. When atmospheric pressure and wind velocity align, the ocean simply moves into the sky.